we got that over with. Oh, what a great tune. That's such a great tune. Let's get on to Chapter 7, Bellwork. So first, graphing. When I'm looking at this graphing, explaining the transformation, that's just helping you think. You don't have to do that. I'm not grading you on that. That should be represented in your graph. But just looking at this, going over what the transformations are, this right here is going to be a stretch. This right here is going to be right, because this one's opposite with the x, so it's going to be right 2, and this one's down 4. So when you're looking at your point's always left and right. Well, I moved right 2, so that's a positive 2. So when I look at my table, my point goes in the middle. So that means I'm also going to test 1 and 0, because 2 on the left, and 3, so 3, and 4. So this is where I go into my calculator and push y equals, and I have 5. And then in parentheses, you do the 6 raised 2, x minus 2. Depending on your calculator, you might have to put x minus 2 in parentheses so it knows it's raised that whole thing. And then go to your table. So in your table, 0 is equal to about negative 3.9. That's a 3. 1 is equal to negative 3.2. 2 is equal to 2. 1. 3 is equal to 26. And 4 is equal to 176. I'm not even going to try to plot the last two, but it's good to have. So my point is 2, 1. For collapse-asymptote, I moved down 4, so y is equal to negative 4. So that's the first thing I'm going to plot here, is my dotted line. Remember, that's going to be 1 point on your test. Just that dotted line. And then my point's 2, and then a positive 1. Woo! And I have 1, negative 3, 1, 2, 3.2. 0, negative 2.9, and I'm not going to get the other 2 on there. That's going up really fast because of that stretch. My range, it's above, so y is greater than, and my horizontal asymptote is negative 4. Moving on. So you're going to have to be able to write it as a log. You're going to have to be able to write it as an exponent. So your first question on this is always, what's my base? What is my base? Well, for this first one, my base here is 2, and it's exponential, so I have to do a log little 2, base 2, and whatever it's equal to is now what you take the log of. Whatever the exponent is now becomes what it's equal to. It's always flip-flops. Turning into exponent, what is my base? So I have 8. Whatever it's equal to becomes your exponent, and whatever you took the log of now is what it's equal to. Write as one single, just one log. So this first one, I see subtraction. So if I see subtraction, that's division. If anything is multiplying, that means it becomes an exponent. Now this is in parentheses. You want to leave that in parentheses. X to the 9th on top, x minus 4 on bottom, raised to the 7th power. Leave that exactly how it is. Do not do anything with that. You cannot distribute that 7 because that's saying x minus 4 times x minus 4 7 times. You'd have a long foiling process for that one, so don't do anything with that one. And I'm going to try to get a little log. Base b, you have to have that little b there. Log base b. Again, this becomes an exponent. This is adding, so this becomes multiplying. So a to the 4th times, you don't have to have that multiplication, but you sure can if you want to, v to the 12th. Next, expand. Expand the log. When I'm looking at this, you should always say, okay, how many things do I have here? I have 1, 2. I should be writing a log base 3. This is part of the log. Log base 3 2 times. So I have log base 3x, log base 3, 4. Then think, okay, if this is division, what should I put in between these? Subtraction, you're right, because you're so smart. Solving. One time I had someone ask me, when I'm doing these videos, when I shake the screen like this, does that mean that that's the hard one? No, I don't do that on purpose. But if I did, I'd be like going crazy with this right now. This is the hard one. Ah. Okay? But let's get down to it. Let's get down to business. To defeat the Huns. this is not part of the log. So I'm going to add 8. That's my first step. These all have logs with them. So since they all have logs, I'm going to write this as one single log. So I have log. I see subtraction. We write my division. 4 goes on top. This 2 becomes an exponent. That is being subtracting, so that goes on bottom. This 2 becomes an exponent. This is adding here, so this stays on top. Is equal to 8. That's what I have so far. Then you think, what is my base? Remember, if there's no number given, it's always base 10. So I have 10 raised to this side, 10 raised to this side. So these two cancel each other out. 4x squared over 9, 3 squared is 9, is equal to 10 to the 8th. Now I can change that 10 to the 8th, but I'm not, because I think it will just be easier. First thing I want to do is multiply by 9. So I have 4x squared is equal to 10 to the 8th times 9. Next thing I'm going to do, I'm going to move over here. So I'm going to divide by 4. Divide by 4. So x squared is now equal to 10 to the 8th times 9 divided by 4. Now I'm taking the square root of that. So x will be equal to the square root of 10 to the 8th. That's raised to the 8th power. So in your calculator, you're doing your square root. You're typing in 10 raised to the 8th power times 9. Make sure that's not an exponential spot anymore, and then divide by 4. Type it all right there into your calculator. You should get your answer of 15,000. Bing, bada, boom. Very last one for bell work is, what is my base? Base here's 4. So I know I have to do log base 4. Whatever I do to one side, I have to do to the other side. It's a must. Keep it even, Steven. So now this is my equation. These two cancel, leaving you with just the x. Subtract 3. And if you go to the math button, go to your log base, or you're going to have to do log of 128 divided by log of 4, depending if you have the older calculator. You type that right into your calculator, you get 3.5. Add the 3. Add the 3. X is equal to 6.5. And that's all I have for you. So make sure that you know what you're doing. I'll be in school in the evening if you so wish to want to come in. Have a great day if I don't see you.